Welcome to the DIY Honda Garage channel. The DTC P0172 indicates a fuel system too rich condition that is relevant for the Honda Accord models between 2008 and 2012. This diagnostic trouble code, DTC, signals that the air-fuel mixture in the engine is too rich, leading to excessive fuel and insufficient air. The primary component implicated in this scenario is the mass airflow (MAF) sensor, which measures the volume and density of air entering the engine. If this sensor fails or gives incorrect readings, it can lead to an imbalance, causing the fuel system to deliver more fuel than necessary. A rich fuel mixture can result in poor fuel economy and increased emissions, and can potentially cause engine damage if not addressed promptly. Understanding the role of the MAF sensor, its location near the air intake, and the common causes for this DTC is crucial for effective troubleshooting. The primary component responsible for triggering DTC P0172 is the mass airflow MAF sensor, located in the intake air duct of the Honda Accord. This sensor plays a critical role in measuring the amount and density of air flowing into the engine, which is essential for calculating the correct air-fuel ratio. If the MAF sensor detects less air than is actually entering, the engine control module, ECM, compensates by increasing the fuel delivery, resulting in a condition where fuel is too rich. Additionally, related components include the fuel injectors, air-fuel ratio, AF, sensors, and the manifold absolute pressure, MAP, sensor, which also impact the overall air-fuel mixture. A malfunction in any of these components could lead to the MAF reading inaccuracies, prompting the diagnostic trouble code P0172. Therefore, meticulous examination and understanding of these components are vital for effective diagnosis. There are several possible causes for the fuel system showing a rich condition, as indicated by DTC P0172. Firstly, aftermarket fuel system components could disrupt the intended fuel flow and pressure, leading to an incorrect air-fuel ratio. Secondly, debris or dirt accumulation in the MAF sensor can lead to erroneous readings, causing the engine computer to miscalculate the required amount of fuel. Additionally, if the fuel injectors are malfunctioning or leaking, they may deliver excessive fuel into the combustion chamber. Contaminated engine oil can also lead to increased oil consumption, which can affect overall engine performance and fuel trim values. Lastly, a faulty air-fuel sensor may fail to accurately assess the fuel mixture, leading the ECM to enrich the fuel slightly more than necessary. Knowing these potential causes lays the groundwork for an effective troubleshooting strategy. When DTC P0172 is triggered, drivers may experience several noticeable symptoms that indicate a rich fuel condition. One of the most immediate symptoms is poor fuel economy, as the engine consumes more fuel than needed to maintain safe operation. Increased emissions are also a common issue, primarily due to unburned fuel being released through the exhaust system, leading to failing emissions tests. Furthermore, drivers may notice rough idling, where the engine's RPM fluctuates and runs inconsistently while at rest. In severe cases, the engine may even stall due to the excessive fuel flooding into the combustion chamber. Identifying these symptoms helps to quickly determine whether DTC P0172 is affecting vehicle performance, necessitating further diagnostics. The first step in troubleshooting DTC P0172 is confirming the failure while the engine is idling. Begin by starting the engine and allowing it to idle in a no-load state, which means in park or neutral for automatic transmissions, AT, or neutral for manual transmissions, MT. While the engine is idling, Monitor the short-term fuel trim, AFFB, using the Honda Diagnostic System, HDS. If the AFFB value reads 0.85 or less, it indicates that the fuel trim is too low at idle. In this case, you would proceed to step 3, as there may be additional underlying issues affecting the air-fuel mixture. However, if the AFFB is acceptable, which means it is greater than 0.85, you would move on to step 2 for additional checks. Making sure to document these values is essential as they provide context for accurate diagnosis. The second step in the troubleshooting process for DTC P0172 involves examining the vehicle's onboard diagnostic snapshot. This snapshot captures various engine parameters at the time when the AFFB ST fuel trim was at its lowest point. Start by reviewing the onboard snapshot data, which should include key values such as engine speed, vehicle speed sensor (VSS), throttle position sensor (TPS), and accelerator pedal position (APP) sensor values. Record these parameters for reference, as they will aid in determining the operation conditions when the AFFB was low. Following this, you'll want to drive the vehicle to replicate the same conditions and recheck the AFFB. If it again reads 0.85 or less, this indicates a recurring issue, prompting the technician to move on to step 3. Otherwise, if the AFFB is acceptable, the system may be functioning normally at the time of the snapshot. In the third troubleshooting step for DTC P0172, the focus shifts to the mass airflow MAF sensor, specifically checking for debris. Begin by removing the MAF sensor from its housing carefully, ensuring not to damage any connectors or wiring. Once removed, visually inspect the sensor for lint, bugs, or any foreign objects that can obstruct airflow. If debris is found within the MAF sensor, it can cause inaccurate readings regarding the air volume entering the engine. Remove this debris, and it is also advisable to use a vacuum cleaner to clean out the air cleaner housing thoroughly. After cleaning, reinstall the MAF sensor and continue to step 4 for further diagnosis. On the other hand, if no debris is found, the next step is to thoroughly check the sensor condition and function. The fourth step involves checking the fuel pressure under conditions defined when the AFFB showed a low reading. To do this, you will need a fuel pressure gauge to monitor the fuel pressure accurately. The required fuel pressure for the 2008 to 2011 Honda Accord L4 models should be between 48 and 55 psi. It's crucial to conduct this test while ensuring that the AFFB is still reading at or below 0.85. If the fuel pressure matches or is within specifications, you can confidently proceed to the next step for further evaluation. However, if the fuel pressure is found to be outside the specified range, this implies that there may be an issue with the fuel delivery system, including the fuel pump or a clogged fuel filter. In such a case, it may be necessary to replace the fuel tank unit before proceeding. The fifth troubleshooting step focuses on examining the readings from the mass airflow MAF sensor while the engine is running at a consistent speed. Start by revving the engine to 3,000 RPM and maintaining that speed until the radiator fan engages. During this time, confirm that the engine coolant temperature ECT sensor value exceeds 158 degrees Fahrenheit, 70 degrees Celsius, and that all electrical loads are turned off. Using the Honda Diagnostic System, HDS, check the MAF sensor's data readings, which must fall within a specified range relevant for the model being tested. For 2008 to 2011 Honda Accord L4 automatic transmissions, the expected MAF sensor reading ranges from 6.5 to 9.1 grams per second, while for manual transmissions, it should range from 5.6 to 7.8 grams per second. If the readings are acceptable, the MAF sensor functions correctly. and you would then advance to step 6. However, if the readings are outside acceptable parameters, further investigation is needed, which may involve inspecting the air cleaner assembly for damage. In the 6th troubleshooting step, it's vital to check the engine oil for contamination, which could impact the overall performance of the vehicle. Start the engine and let it idle while monitoring the short-term fuel trim AFFB using the Honda Diagnostic System HDS. Next, gently pinch the hose that connects the positive crankcase ventilation PCV valve to the intake manifold. This action helps isolate the PCV system's effect on the air-fuel mixture. If the AFFB reading increases above 0.80 when the PCV hose is pinched, it indicates that oil contamination is likely affecting engine performance. In such a scenario, the recommended action is to replace the engine oil and oil filter to rectify the situation. If the AFFB does not show an increase after pinching the hose, this suggests that the engine oil is in acceptable condition, allowing you to proceed to the next step of troubleshooting. The 7th step in the troubleshooting procedure involves replacing the fuel injectors if prior tests indicate issues. Start by installing a set of known good fuel injectors to ensure the injectors themselves are not causing the abnormal fuel trim readings. After replacing them, operate the vehicle under the same conditions observed when the AFFB reading was 0.85 or less, effectively putting the system to the test. If after this operation, the AFFB reading remains at or below 0.85, it confirms that the issue was not due to the fuel injectors. In this case, you would proceed to step 8 to investigate other components that could lead to the rich fuel condition. On the contrary, if the AFFB reading normalizes, the investigation confirms the fuel injectors were indeed the source of the high AFFB value, allowing you to proceed to step 10 for system confirmation. The 8th troubleshooting step entails replacing the air-fuel AF sensor if previous steps indicate that the fuel injectors were not at fault. Begin by installing a known good AF sensor in place of the existing one. Once replaced, operate the vehicle again under the same conditions where the AFFB reading had previously shown a value of 0.85 or less. It is crucial that this test reflects the same driving scenario for a valid assessment. If the AFFB reading still remains at or below 0.85, this would mean the AF sensor is not the root cause of the high fuel trim readings. If this occurs, you will then move on to step 9 to explore other potential issues. However, if the AFFB reading improves, it indicates that the AF sensor was indeed faulty and has now been rectified by the replacement, allowing you to continue with confirming your repairs. In the 9th troubleshooting step, you need to consider the possibility of fuel-related issues, particularly if the problem arose shortly after refueling. Begin by removing the fuel tank unit and draining the existing fuel to eliminate any potentially contaminated or poor quality fuel. After draining, refill the tank with known good quality fuel that meets manufacturer specifications. Then, operate the vehicle under the same conditions that resulted in the low AFFB reading to analyze the effects of the fresh fuel on engine performance. If the AFFB still remains below or at 0.85, it suggests that the fuel was not the contributing factor to the problem. In this case, you should substitute a known good engine control module, ECM, or powertrain control module, PCM, and then progress to step 10. If the new fuel resolves the issue, it indicates that the previous fuel was indeed the cause of the high AFFB reading. The final troubleshooting step for DTC P0172 involves confirming that a successful repair has been conducted. Start by turning the ignition switch to the on position without starting the engine. Next, reset the Engine Control Module, ECM, or Powertrain Control Module, PCM, using the Honda Diagnostic System, HDS, which erases stored trouble codes and resets learned parameters. Follow this with performing the idle learn procedure for the ECM, ensuring that it recalibrates the fuel control strategy. After performing these steps, start the engine and hold it at a controlled speed of 3,000 RPM for a set period until the radiator fan engages. Then allow it to return to idle. Finally, monitor the AFFB reading once more under the same conditions that previously indicated a low value. If it remains above or at 0.85 now, the system tends to still be problematic, prompting a return to the previous troubleshooting steps. However, if the reading shows normal operation levels, it indicates that the repairs were successful, effectively rectifying the issue. In the final repair verification step for DTC P0172, it is essential to reassess the AFFB values to ensure that all repairs have effectively resolved the issue. After completing the troubleshooting and necessary repairs, monitor the short-term fuel trim using the Honda Diagnostic System, HDS, once again. This will help confirm that the fuel trims are now operating within acceptable ranges and that the vehicle is performing normally under various load conditions. Ensure to document this successful repair process along with the final AFFB values captured during tests for future reference. This comprehensive documentation serves as a valuable resource should similar concerns arise in the future. By verifying the successful repair and establishing a baseline for normal operation, you provide the necessary assurance to the vehicle's functionality and adherence to emission standards. To prevent recurring issues associated with DTC P0172, incorporating regular preventive maintenance is crucial. Consistent inspections of the mass airflow MAF sensor, fuel injectors, and other fuel-related components can help identify signs of wear or buildup that could affect performance. Cleaning the MAF sensor at routine intervals is a great practice, as it helps maintain accurate readings that are essential for optimal fuel delivery and air-fuel mixture. Furthermore, always opt for high-quality fuel that meets the manufacturer's requirements, as this improves combustion efficiency and decreases the potential for deposits forming in the fuel system. Regular checks of engine oil quality will also ensure that it remains uncontaminated, thus preventing oil-related issues that might lead to elevated fuel trims. By prioritizing these preventive measures, vehicle owners can significantly reduce the likelihood of encountering the DTC P0172 in the future, ensuring better engine performance and reliability. In conclusion, DTC P0172 signifies a critical issue regarding a rich fuel condition in Honda Accord models from 2008 to 2012. Numerous factors can lead to this situation, primarily stemming from issues with the mass airflow MAF sensor, fuel injectors, or contamination in engine oil. Proper diagnostic steps, beginning from confirming failure during idle, up to reviewing fuel quality, help systematically identify and resolve the root cause. Additionally, engaging in regular maintenance tasks, such as inspecting fuel injectors, cleaning the MAF sensor, and ensuring high-quality fuel usage can work wonders in preventing future occurrences of DTC P0172. Ultimately, following these measures not only aids in maintaining engine performance, but also aligns with adherence to emissions standards, contributing to both environmental and operational health of the vehicle. Please like and subscribe to the channel. See you next time!